Hello, welcome to Z Talk. This session, we're going to continue to discuss about automation via Terraform on AWS. Specifically, I'm going to talk about AWS IAM, Identity and Access Management. Stay tuned. All right. So IAM, Identity and Access Management, it's a crucial service part of AWS for authentication and authorization. It ensures us to manage access to AWS resources and services in a secured manner. How does it work? The first concept is called principal. It's an entity that performs actions on an AWS resource. It could be a real user or it could be an application. Generally, anything that needs to perform some actions on AWS resources could be a principal. A principal requires credential or private key for authentication. After that, the principal sends a request specifying the action and which resources should perform this action to AWS IAM. IAM gonna review this request and approve it if the request is allowed by a matching policy. And then the action will be performed. It could be view, create, edit, or delete a resource, something like that. You name it. All right. Here is the list of components of IAM. Let's start from the first one, users. Like I mentioned just now, it could be a real person or it could be an application. Each user is associated with only one AWS account. So you just can't create a user across multiple AWS accounts, which is not allowed. The second component is group. Group is a collection of IAM users. It's used to specify permissions for multiple users who require the same permission. And permission applied to the group will be applied to each individual user automatically. So let's say any new member of a group inherits whatever permissions once it's added, right? The third component is called policy. Policy sets permission and controls the access to the AWS resources. It's a JSON format data document and permission. Permission specifies who has access to the resource and what actions they're able to perform on that resource. All right. And the last component is called rules. A rule is a set of permissions to define what action are allowed. That's pretty much it. Okay, let's quickly jump to the demo. So in this demo, we're gonna create multiple IAM users and create groups, create rules, create policies. So let's do that real quick. And before I jump to my demo, just remember, feel free to leave comments if you have questions, and sum up and subscribe my channel if you haven't done so. All right, cool. All right, I copied a couple of files from my previous code base as a preparation ahead of time. Basically, these 4 files, which includes my private key, public key, and the account information, like providers is just my access key, secret key, and region for my AWS account. And in the variable.tf, is just define these variables and assign values to the variables, right? So in here, we're gonna create another Terraform file called IAM_users, where we're gonna define a couple of IAM users and a group, and then we're gonna assign the users to the group, and lastly, we're gonna attach some random policies to the group so that the users who belong to that group gonna have some permissions to get access AWS resources. All right. So let's start with definition. So I will create two IAM users. Again, so if you're not familiar with the syntax, so documentation is our Bible, right? So just go to Terraform registry and search for AWS IAM module, and here it lists out all the resources available, and click that, you will see examples, right? So let me jump back to my Visual Studio Code and create resource. Let me start with resource AWS IAM user. I will give the variable like user01. All right, and then I'll give a name equal user01. Same thing, I'm gonna create another user and a resource, and in a group, right? So just here. So here is create another user called user02, and here is I created a group. So let me stop here, go to my AWS portal, and here and go to IAM. So out of the box, we can see there is a user created. That's the user, Terraform user with admin permission I created a long time ago when I started this session, serious session, right? So let me just jump to policies, and here it lists out all the policies available. So there are lots. Let me just random pick something. Let me search for example, EC2. All right, so I'm gonna use this Amazon EC2 container registry power user policy as example. All right, so let me go back to my, I'll copy this guy. I'll use the name of this policy as the variable name for this group. So EC2 container registry power user group. All right, and then I'm gonna assign the users to this group. Let me do that. So the resource name is AWS IAM group membership, and inside of these resource, there is a users parameter. So it's the list, right? So I can include all the users that who I want to assign to this group. Here is user01, user02. All right, and the group name, of course, is here. So EC2 container registry power user group. All right. The last but not least, I'm gonna assign that policy to this group. For attaching policy, one parameter you need to understand is called policy ARN. ARN is kind of a format. Let me go to the documentation. And ARNs basically is called AWS resource names, and the permissions policy language requires you to specify the resource or resources using the following ARM formats. Here, I give an example of the format of these ARM resource names. All right, so let's just follow this format and create the attachment. The attachment, let me jump back to the Visual Studio Code, and the resource for attaching policy to this group is called AWS IAM policy attachment, and I give the variable name as attachment. And here the parameter, one of the parameters is groups. Basically, you can attach multiple groups to these policy. Attach policies to multiple groups. It's a list, right? So I put in the group, that I just created above. And here, that's the policy R, right? So we're gonna assign these policy to these group. All right, that's pretty much it. Let me jump to my terminal and see if it works. So let me just issue a Terraform plan to see if there any error pops up. All right, pretty good. So looks it's worked, and as planned, there are gonna 5 resources created, and let's issue Terraform apply. And type yes to approve. And here we go, apply complete. If you couldn't see here, let me move up kind of above. So here it shows apply complete, 5 resources were added. So let's verify by logging to my AWS portal and click IAM, and then click just click IAM here, and you can see now there are 3 users out there and 2 groups. Let's go to users first, and you can see the user 01 and user 02 were created, and they both belong to these group, the group we created called EC2 Container Registry Power Use Group, right? So if we click into the user, and we can see the policy, Amazon EC2 Container Registry Power User policy was assigned to the group. Because it's assigned to the group, and the user automatically inherits the policy from the group. All right, pretty cool. And just one thing to pay attention when you test it out on your environment. For picking policies, I just random pick that policy, right? So if you test it out, and please do not use these administrator access. Basically, these policies grant admin permissions to a user, like let me go to users, and the Terraform. This is the user I created a long time ago, right? Which who has the administrator access policy attached, right? So when you test that on your end, if you randomly pick these administrator access to your Terraform configuration file and apply to the attach these policies to a group, if that's the case, do not run Terraform destroy anymore, because if you run that Terraform destroy, it's gonna destroy these users you created, the group you created, and somehow when I tested, it's gonna affect your administrative permission, like the one I created, this one. Even these not part of the automation via Terraform, because you were using that Terraform administrator access policy. If you run Terraform destroy, somehow it's gonna affect your existing user. So do not use that policy. Other than that, you will be good. Just feel free to test it out on your end. All right. Okay, we were able to create an IAM users group and attach policy to that group, right? Now let's extend the demo further to create a custom role and a policy. Let's set up a use case, right? The use case will be the role will be able to get access to a S3 bucket. Being said of that, we will need to create a S3 bucket, and then we're gonna create the custom rule and a policy, and attach that policy to these S3 buckets for allowing request from a EC2 instance. And then we're gonna associate a role with these EC2 instance so that we will able to verify if the EC2 instance is able to access to the S3 bucket without any authorization. All right, that's pretty much the use case. And for doing that, we're gonna have to create another couple of Terraform configuration file. And also I copied another file from my code base, create instance at Terraform. If you watch my previous video, you know what these file for. Basically, it's just for spinning up a EC2 instance. So I did not change anything. The only difference was I take the VPC out, because for this demo, I don't have to create a VPC on my own. So I just use the default network. All right. I keep the rest as same as it was, and I will make a little bit change shortly. So let's start with the other two files we're gonna create for this demo. The first one, as I mentioned, I'm gonna create a S3 bucket. All right, so I create a file called S3 Bucket.terraform. That's where we're gonna define this S3 bucket instance. All right, so the resource is AWS S3 Bucket, and I name this variable custom -S3 bucket -01. And for ACL, which is access control list, I made it as private, and I give this bucket name bucket_demo. All right, it's pretty straightforward. Now let's move to the important one, the another file create called IAM_role. That's where we're gonna define our customer role and policy. All right. So here I list out the framework inside of this configuration. So firstly, we're gonna create a role and assign assign the AWS S3 bucket, and next we're gonna create a policy to attach to the S3 bucket role we created above. And last but not least, we're gonna create a instance identifier. Basically, that's what I'm talking about earlier. For this file, I'm gonna make some a little update over there, right? So basically, I'm gonna create a identifier and then add that identifier to the instance. So so that instance is going to be the one we for our testing to verify if we can use that instance to get access to the S3 bucket. All right. Cool. Let's start with step one. Create a role to access the AWS S3 bucket. So again, the Terraform registry is our Bible. So if you're not familiar with the resource or the syntax inside of the resource, go there. So let me go there real quick. So AWS IAM role, right? So here it lists out a basic example what it look like. So I'm gonna use this as my example as well. So especially here, the assume role policy, I'm gonna use pretty much the same thing, right? Because our use case is same. The principal service will be a EC2 instance, right? So let me go back there. So this is the AWS IAM role resource I created, and here you can see the principal service is a EC2 instance. The effect is allow. All right. Now let's jump to the next step. Policy. Create a policy to attach to this role. All right. So what we're gonna do? We're gonna go back to the registry, and this is the resource we're gonna use. AWS IAM role policy. This resource provides an IAM role inline policy. So follow this example again. So let me go back to my Visual Studio Code, and here I create a resource called AWS IAM role policy, and the role will be the one I just created above. So AWS IAM role S3 bucket role, S3 bucket role, right? And the policy here, just pay attention. The action is on the S3 instance, right? And here I specify the resource. So just remember, it has to be two statements. The first one is for is telling so I need to get access, allow access to these S3 buckets I created. Basically, this is the S3 bucket I create over here, custom S3 bucket 01, right? So custom S3 bucket 01. So these statements provide authorization to get access to these S3 bucket instance. And the next one, so is the component inside of this instance. It also requires authorization to be able to get access all the contents inside of these S3 buckets. All right, cool. And then let's move to the last one, create an instance identifier. This one is pretty easy, and we just need to do that resource AWS IAM instance profile, right? And we will give it a name. Let's call it S3 bucket role instance profile. I'll give a name, same as the variable. Let me just copy that. And then we're gonna give the role. The role will be the one I just created above. So it's gonna be AWS IAM role dot the role I created here dot name. All right, that's it. And then the last but not least, I need to add these identifier to these EC2 instance I'm gonna spin up. I'll go here. Add another item, excuse me. So it's IAM instance profile, and I will point it to that guy. So it's AWS IAM instance profile dot S3 bucket role instance profile. The name. That's it. Let's test it out. Let me go back to my terminal. Here, all right, so let's do a Terraform plan to see if there are any error pop up. Okay, looks good. It passed the validation, and there will be 11 resources added. So let's do apply. Yes. You can see the group is creating, user is creating. By the way, you don't need these IAM_users anymore, because for this demo, we don't have to create a users. This one was for the previous step of the demo. So, but it's not a big deal. You can leave it there, or you can delete it. Either way. And then you can see the S3 bucket role is creating, and now it's creating the EC2 instance. All right, so it's complete, and there were 11 resources being added. And this is the public IP address of the EC2 instance. Let's verify by logging to my EC2 portal, and let me refresh. There should be an EC2 instance up and running. Here we go. And let's also verify the and you can see the IAM role, S3 bucket role, was attached to these, associated to this EC2 instance, right? Let's also verify let's also verify the S3 bucket. There should be a S3 bucket created. Let's go to S3. And here we go, custom S3 bucket 01. That's the one we just created, right? Cool. Looks it worked. Now the next step is gonna be verification. How are we gonna verify? We're gonna get access to this EC2 instance, and then we're gonna create a test file, and we're gonna transfer, basically copy that file to the S3 buckets. If it works, it verifies these. We were able to get access to these S3 buckets from the EC2 instance, right? So let's do that by firstly logging into these EC2 instance. Let's do a SSH. The IP address, the username will be Ubuntu, and let me add my private key, my key. Okay, now I logged in. So let me sudo to root, and where am I? So I'm under home Ubuntu directory. Let's create a file. Welcome to ZTalk. And I'm gonna save the string to a file. Let me call it test.log. All right. Here we go. Let's do ls. So here's the test file right here. If I cat this test file, and basically it just store the string I just type in. Will come to ZTalk Terraform sessions, right? So now what we need to do is we need to copy this file or transfer this file to the S3 bucket. How do we do that? We're gonna need AWS CLI. So in that case, we need to install AWS CLI first. But there are some dependencies. For be able to install AWS CLI, we're gonna need Python and pip. So let's do that. So let's do apt-get update first. And then let's install Python. Oh, sorry. Okay, Python was installed successfully, and the next one we're gonna use pip to install AWS CLI, right? So pip, yes. Okay, Python is ready, pip is ready. Now we're ready to install AWS CLI via pip install AWS CLI. All right, so now for installing the now for copying this file to S3, we need to issue a CLI command, AWS copy S3, the file and S3 instance. Let me give the instance name. Get back to here, the name of the instance is custom S3 Bucket 01, right? Hit enter. Oh, so it seems I type in the wrong AWS S3 copy. All right, so here it should upload task log to S3. It was done. So let's quickly verify. So let me refresh my portal and log in here, custom S3 Bucket 01. Here we go. The task.log was successfully loaded to the S3 bucket. Cool. Basically, it's verified. All we created worked. All right, let's move to the next one.
All right, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.